Okay, this lesson is for April 3rd. Let me make sure we're videotaping. Yes, we're rolling. So this is April 3rd. We're going to talk about the whole concept of correlation. So we've been talking about residuals, about how that tells us how far from the actual it is. So correlation is basically us looking at the data and saying, does it make positive or negative correlation? So if you look on page 135, we're on lesson 19. This is our last lesson on scatter plots. We're going to talk about how when data has a tendency to move up, it would be a positive correlation, and where it moves down would be a negative correlation. And the following questions just basically asks us to make a reference to the fact that when the data on the X goes up, the data on the Y goes up. That would give us a positive correlation. But on the negative side, if the data on the X goes up, the Y goes down, which makes it a negative graph. So that's just basically for 3 and 4, what they put into a simple question for us to review. So if the X goes up, the Y goes up. But if it's a negative relationship, the X goes up, the Y goes down. So now we're going to talk about how strong and how weak data can look. So if you look at example 2, it gives us 2 positive correlations, but this one is much weaker than this one because you notice that all of the dots are kind of around, spread out more, whereas this is more in line with tight around the line of best fit. So this was what we would consider a strong correlation, and this would be considered a weak positive correlation. If we go to S137, they want me to model. I'm going to model some examples of a strong and a weak linear correlation. So this would be a strong positive correlation because all of them are tightly packed around my line of best fit and they're all in a positive direction. This would be a strong negative correlation because they're tightly packed around the line and they're going in a negative slope direction. So when we talk about strong and weak, and if you look at letter number 10, they want us to kind of put them in the correct order. Well, I can tell that this is the strongest because the dots are very close to the line. And this would be the next strongest, with this one being the weakest because the dots don't make that strong line connection. It seems like what I'm telling you is easy. It's actually that easy. It's not anything difficult to look at. Looking at 12, they give us 2 quadratic examples, and they're both very much a parabola shape, but this one would probably be a stronger example because it's more reflective on either side, whereas this one is a little more skewed. Now, they do assign a number for how strong the data looks, and that's called the correlation coefficient. So example 3 talks about that. And basically what it talks about is the fact that it assigns it a numerical number. It's a value that tells me if the data is strong or weak. If the data number for the correlation coefficient is close to -1 or +1, it is very strong. If it is close to 0, it's considered weak. So if we look at these examples, the first one is 1. It's very close to 1 because it is 1. So therefore, the correlation coefficient shows a very strong relationship. The line makes a perfect straight line. If I move on to my next example, 0.71 is still very strong. The correlation coefficient is closer to 1 than it is 0. 0.32 is much weaker because it's closer to 0. -0.1 is very weak because it's close to 0. -0.32 is also weak because it's close to 0. But once I get a -0.63, that is getting stronger because it's closer to -1. It doesn't matter if it's -1 or +1. If as long as it's close to that whole number 1, then it is considered strong. And then a -1 is considered very strong data. So a +1 would be a positive correlation and a -1 would be a negative correlation, but everything in between is going to tell you if it's weak or stronger. So for this lesson, what I would like for you to do is just answer the questions on S147, number 1 only. So you just have 3 scatter plots to answer if they're strong or negative. Okay, and that'll be it for scatter plots. We're not going to do lesson 20, and that'll end the module on data.